Hey Algebra 2 students, today we are going to learn 6.6 solving equations with radicals and rational exponents day 2. Today we're going to see that sometimes to solve these equations with radicals we have to square both sides or cube both sides twice. So before we do that, a helpful reminder that a plus b quantity squared expands to a squared plus 2ab plus b squared. What I think a lot of you do is this, a plus b times a plus b, and then FOIL, which is great. That will get you to that as well. But if you would like to use this pattern, sometimes that speeds things up just a little bit. Alright, so here we go. We're going to look at a couple examples, and then I'll have you try a few for class. So we're going to solve both sides. We're going to check for extraneous solutions. If you notice from yesterday, we had to isolate the radical. However, in these, there are two radicals, and this plus one, minus one right here is an issue. Whether if I move it over here, that radical is still not by itself. So we're going to have to deal with the minus one when we square that radical. So I'm going to go ahead and start by squaring both sides. When I square the right, okay, it does take off the square root. So the square root of x minus 3 squared equals x minus 3. But when I square this side, notice that I have two terms. If we think about the slide before, the a plus b, this would be my a term, minus 1 would be my b term. So I have two terms there. I'm going to first show you the FOIL method. So if I write it out twice, x plus 2 minus 1 times root x minus 2, x plus 2 minus 1, which clearly I've left plenty of space there. So now we have to FOIL this right here. When I FOIL, square root of x times square root of x plus 2, these two square roots, well, when you multiply like bases, you add the exponents. Remember that these exponents both have an exponent of 1/2, so 1/2 plus 1/2 is 1, which means the square roots go away. I end up with x plus, sorry about that. Come back. Okay, so I end up with x plus 2. When I distribute, oh my goodness. Okay, so now when I distribute to this term, I get minus square root of x plus 2. When I go here, I get minus square root of x plus 2, and go this way, plus 1 equals x minus 3. Now I've got a lot going on here. I'm going to clean up my like terms, and again I'm going to isolate this radical term. So how many radical terms do I have there? Well, I have two, so minus, I have an x, I do not know what this computer is doing. Here we go. I have an x plus 3, those two go together, minus 2 square root of x plus 2 equals x minus 3. Okay, so now I'm going to subtract over my x. I'm going to subtract over my 3, and I have negative 2 square root of x plus 2. These x's cancel, equals negative 6. I'm still working to isolate this radical, so I'm going to divide both sides by negative 2. So square root of x plus 2 equals 3. Wow, that was a lot of work just to get this radical isolated. I still need that radical off there, so I'm going to go ahead and square both sides again. So square root and squared undo each other. I get x plus 2 equals 9. Subtract 2, x equals 7. So let's come over here. We need to check just like we did yesterday. So when I check, I get the square root of 7 plus 2 minus 1 equals the square root of 7 minus 3. So I get the square root of 5, that's 9, sorry, minus 1 equals the square root of 4. So 3 minus 1 equals 2, 2 equals 2, checks, that works. Okay, so let's review what we did here one more time. I started by squaring both sides. When I square two terms, I have to FOIL to undo those. Okay, then I collected like terms, moved everything over to the other side to isolate this radical, got the radical all by itself, and then got my solution. Finally, I make sure I check. Okay, let's try it again. Okay, so similar thing here. Notice I have a plus 3 and a minus 2, so if I can get rid of one of those like terms, I will. So I'm going to go ahead and start by subtracting 2. Oops, try that again. Okay, so I'm going to start by subtracting 2. And so I get the square root of 2x plus 6 plus 1 equals 4x plus 5. So I couldn't completely get rid of both of those, but 1 is better than 2 numbers out there. So now I start by squaring both sides. On the left, I'm going to have the square root of 2x plus 6 plus 1 times the square root of 2x plus 6 plus 1 equals square root and squared undo each other, so 4x plus 5. I'm going to FOIL over here, or if I wanted to use the pattern from the first slide, I could. So root 2x plus 6 times 2x plus 6 is just 2x plus 6 plus root 2x plus 6 plus 2x plus 6 plus 1 equals 4x plus 5. Clean up my like terms. So I have a 2x plus 7 plus 2, 2x plus 6 under the radical equals 4x plus 5. I'm going to subtract my 2x, I'm going to subtract my 7, and I get 2 square root of 2x plus 6 equals 2x minus 2. Now I'm going to divide everything by 2. And I get square root of 2x plus 6 equals x minus 1. Now I'm going to have to square both sides again because I still have that radical in there. So now I'm going to come up here, and I have 2x plus 6 equals, and I'm going to go ahead and use the pattern. This would be x squared minus 2x plus 1 when I expand that. Or if I FOILed x minus 1 times x minus 1, that's what I would get. Notice I've created a quadratic, so I've got to get all my terms on the same side. I'm going to subtract over my 2x, subtract over my 6, and I get 0 equals x squared minus 4x minus 5. I'm going to factor x minus 5, x plus 1, and so my solutions are 5 and negative 1. Yikes. I still need to check my solutions. So, when I check, okay, what I don't want to get is a negative under the radical or a solution that's not true. So, I get square root of 2 times 5 plus 6 plus 3 equals 4 times 5 plus 5 plus 2. So I'm going to have to do a little mental math because I'm running out of room here. I get 16, square root is 4, plus 3 is 7. Here I get 20 plus 5 is 25, square root is 5 is 7. So that first solution of 5 checks. Okay, now I need to check negative 1. I get square root of 2 times negative 1 plus 6 plus 3 equals square root of 4 times negative 1 plus 5 plus 2. So I get 2 times negative 1, which is negative 2, plus 6 is 4. Square root of 4 is 2, plus 3 is 5. On this side, I get 4 times negative 1, which is negative 4, plus 5 is 1. Square root of 1, I get 3 on this side. Not true, so what am I going to do? I'm going to come back over here. I'm going to go up, and I'm going to say, nope, negative 1 does not prove a true statement. Okay? So these problems are pretty involved. Okay, I want you to try 2 tonight. Both of these have 2 terms here. Okay, you're going to have to square both sides twice. We'll go over them in class tomorrow. Thanks so much for watching the video. I'll see you tomorrow.